Okay, so here's the AND gate. I'm just going to show you guys a few different ways that you can make it. Before I'm going to show you how to make it. Well, two ways I made it. I'm going to show you guys basically sort of what the basis of what an AND gate is, in case you don't know. Basically, the way I think about it, or the way you can think about it, is that you can think of it as A times B, as A and B are the inputs. So if you go to the truth table, if you say A and B are 0, then 0 times 0 is going to be 0. That if you say A is 0 and B is 1, then 0 times 1 is 0, and vice versa for the next column, or the next row, But for the last row, you say if A and B are both on, so they're both 1, 1 times 1 is 1. So basically what you learn from this is that in an AND gate, the only time it'll produce an output of 1 or high is when both inputs are on. Okay, so here's two different interpretations that you can use. Basically, one way you can do is create a NAND gate and then invert that output. So I know it kind of looks kind of weird how I wrote it, saying A times B nodded and then not it again, but I think you'll understand later when I show you. A second way that you can do it is you take not A or not B and then invert that output. So as you can see in the bottom, it's not A plus not B and then not that output. That's, by the way, that's DeMorgan's law. And if you look at the truth table and actually do it yourself, it's kind of strange, but it works. So if you take 0 and 0 for the inputs, you're going to say, so you're going to not A, so it's going to be 1, plus not B, which is 1. But in Boolean logic, it only goes up to 1, the numbers, 1 and 0. So the output is going to be 1, and then not that, it's going to produce a 0. And then if you do that for the other ones, you'll find out that it works just the same as A times B. Alright, so this is the first AND gate that I made. Basically, as you can see on this side right here, this is the AND gate, and then the output comes from this white wire down, and then I just knot it using this gate right here. As you can see, these are my two inputs, and yeah, they're just hooked up to the AND gate, and then all you have to do is just knot the output. So I'll show you guys what it looks like. Okay. Okay, so when both inputs are on the high line, then the LED will be on. But if one is off, then it'll not be on. Okay, so this is the second one that I showed you. It's basically you knot both inputs, which are these two wires right here. So you're going to knot them using these transistors. So these are just NOT gates. And then the outputs, which are these these resistors right here, link to the base of this transistor. So basically that's essentially ORing it, and I'm connecting it through resistors so I don't get feedback. But basically, yeah, it's connected to the base of this transistor, so I'm just knotting the ORed output of these two knotted inputs and then wiring it to this LED. So let me just plug that in to show you guys. So when it's on, when both inputs are wired in, or on the high line, the output will be on. If I take one out, then the output will be off.